Thank you for having me here, and this is Large Language Model for Developers. I am Stefano Fiorucci, software and NLP engineer at DeepSet, where I work on the Haystack framework. Haystack is an open source LLM orchestration framework you can use to build application based on language models. So you can do retrieval augmented generation, question answering, semantic search, and several other use cases. The main building blocks of Haystack, they are components that, following the Unix philosophy, they try to do one thing and do it well. And then you can compose you can combine these components and form pipelines, which are directed graphs, which can also contain loops. But yeah, let's start. Why am I proposing this talk? Since the rise of ChatGPT, we have seen a lot of opportunities for developers, for programmers, but also a lot of hype, of noise. And so the idea of this talk is to discover together the main concept with an hands-on approach, with some code. And yeah, this is a talk for beginners with language models, so for programmers, developers. If you have some experience in this domain, you may not learn much, but I hope you have fun. So this is the idea. Let's start simple. What is a large language model? Generally, with this term, we refer to generative models of the transformers family. You pass in input some text called prompt, and you get some other text, which is statistically plausible, as we will see. But how are they trained? This is a very popular image. It is nice. There are three phases: unsupervised learning, supervised fine-tuning, and then human alignment optimization. Let's see it in a more structured way. This slide refers to OpenAI models, so it's not generic, but it helps us to introduce this topic. So the first step is the pre-training from a massive unlabeled corpus, and this phase is very costly, so only a few companies can afford this phase. And at the end of the pre-training, you get a pre-trained model, which is not usable in real world. Let's see an example. If if I prompt the model with how to make pizza, I can get different responses from a pre-trained model. A recipe, which is good, but I can also get how to make pizza for a family of 6, or how to make pizza, how to make pasta. So a pre-trained model just completes your text in a statistically plausible way. And we need these other two phases. The supervised fine-tuning. In this case, we generally train the model on a collection of instructions or multi-turn interactions. And during this phase, the model learns to follow instructions or to chat. And the last but very important phase is the preference alignment. In this phase, the models learns how to align, how to provide helpful responses. In this slide, it is made with reinforcement learning from human feedback, as in OpenAI models, but there are other other simpler techniques to do that. But at the end of the third phase, you have a model which is usable for real-world applications. So let's start. In this talk, I'm using Haystack. It is a framework that simplifies a bit your life, but does not hide much complexity, so can be good, I think, for educational purposes. Here we are importing a generator, which is the main interface for language models, and then I'm using a generator from OpenAI, which is a proprietary model. You have to pass or set an API key, and you pay per generated tokens in this case. And I ask, where is Florence? And I get a nice and right response. All good, but we are at PyCon. We like open source, so why not switching to open models? And so you can do that easily using this project called Ollama, which is akin to Docker for language models. It is based on another project called Llama CPP, but the idea is that you can use a quantized version of this model, and it can run easily on your machine, even if it is a standard machine. Maybe it will be slow, but it's good. It has an integration with Haystack, so in this code we are importing an Ollama generator, specifying the Mistral model. We could also use the more recent Llama 3, Phi3, which open model you want. And we ask the same question, where is Florence? And we get a nice response. We can also chat with this model through an Ollama chat generator. In this case, this type of generator uses the chat message abstraction with a role, which can be user or assistant, and then a content. And here in this while loop, I'm trying to create a simple program to chat with our model. And here there is the output. I'm asking for indications to plan a trip to Florence, to Italy. So, yeah, it looks nice. Just a quick reminder, there are several efficient ways to create prompts for models. There is this discipline called prompt engineering. So I suggest these two resources, OpenAI Guide and this site Prompting Guide, which provides different prompts for different models. So all good, but why do we need more? There are challenges with language models. Here I'm asking who won the 2024 Italian Super Cup, and both the OpenAI GPT 3.5 Turbo and Mistral, they have not been trained and they didn't have this knowledge. So their knowledge is not up to date, and also they don't know about your domain, about your specific data, and yeah, this is a first challenge. Let's try to ask about myself. Unfortunately, I'm not so popular, and so both GPT 3.5 Turbo and Mistral makes up a wrong and not factually correct answer, and these people do not exist, they don't have this name. So yeah, this is an example of an hallucination. A way to prevent this, or to make them reason on a knowledge we provide to the models is retrieval augmented generation. In this case, we are simply trying to inject the knowledge, passing some relevant information into the prompt for the model. So we can think of direct prompting, as we have done, as closed book exam. So the LLM knows or makes up a statistically plausible answer, while RAG is like an open book exam. So it can make sense in several situations. Let's see a very naive example. In this case, we are not doing retrieval. We are creating a knowledge base with some information about the Italian Super Cup. Then we introduce a component called prompt builder. In this case, it uses a template, which is a Jinja 2 template, where we are saying, given this document, answer the question, and we put some placeholders for documents and for question. And we create this prompt builder. Then we combine this prompt builder with a generator in an haystack pipeline. So we add these two components, the prompt builder and then the generator, and then we can ask a question: who won the Italian Super Cup in 2024? And in this case, we get the right response. An evolution of this can be WebReg. So the first step is to ask these questions to a search engine like Google and pick the top K results from Google and then inject them into the LLM. But let's see the most common use cases. Usually you have some data stored in a database. You want to, at query time, you want to retrieve the most important information and pass them to the generator to help the language model to provide an answer. So these are the most common databases which are compatible with haystack. There is a great variety. I'm not going into the details of these databases, but each of them has its own retrievers, so the abstraction to look for the right information from them. And let's talk a bit about retrieval. There are two most common techniques. One is keyword-based retrieval, where the BN25 is the most popular technique. Here, the idea is simple. We have a vocabulary with all the words in all the corpus, and each document is composed by a vector of zeros where the word is not present and a number different from zero where the word is present. And this keyword-based retrieval works well for precise word matching. It's fast, it's quite good, but it can't take semantic meaning into account. But in any case, it is used, and let's see a simple example with haystack. We are using, in this example, the Wave8 database that supports both keyword retrieval and semantic vector retrieval. In this case, we are initializing a document store, which is locally run via Docker, and then we are creating a pipeline with a converter from text to document, then a splitter, which chunks our documents into smaller, more searchable and manageable pieces, and then the writer that writes to the database. And in this case, I'm indexing some textual files about rock music, and this is the indexing part. Then our RAG pipeline with BN25. In this case, the first component is a Wave8 BN25 retriever. Then, as we have seen before, a prompt builder and the generator. And we connect the retriever with the prompt builder and then with the generator. And we ask a question, who is Samuel Thomas Fender? And we get a response. And this is a query which is appropriate for BN25 because it involves precise names and words. But let's talk about embedding and vector retrieval. First, we have to introduce embedding model, which is another type of language model. These don't produce text, but they produce a vector that represents the semantic meaning of the original text. And yeah, a very common library for producing these embeddings is sentence transformers, which is open source, and currently it is maintained by Hugging Face. But what happens when I try to do embedding or vector retrieval? In this slide, yeah, it is about music. We have 3 documents. 2 are about Green Day and 1 is about Jeff Buckley. And then we have our query, who are Green Day, which is projected in the same vector space. And so at retrieval time, probably the documents that are closer to the query, they are retarded. So in this case, probably the documents about Green Day are retarded, and this about Jeff Buckley is discarded. Let's see this in action in Haystack. The pipeline is very similar to the previous one, but in this case, we also have a sentence transformers document embedder that enriches the document with its embedding, its vector representation. And now the RAG pipeline with embeddings, which is also very similar to the previous, but in this case the first component is this sentence transformer text embedder that transforms the query into a vector. Then this vector is passed to the retriever, which looks for relevant documents in the database. Documents are passed to the prompt builder and then to the generator. And in this case, I'm asking a somehow hard question. Audioslave was formed by member of 2 bands. Can you name the bands and summarize the Audioslave sound with a short bulleted list? And this is not only focused on precise word matching, but also on meanings. And yeah, I get a very complex and also true response. Yeah. Both BN25 keyword methods and vector embedding methods have its own strengths. So it could make sense to combine them in embedding retrieval, in hybrid retrieval, so use both of them and then join the results. But I'm not going into details. So, yeah, now this first hands-on part, looks good. And now I want to give you some tips about going from demo, simple application like this, to a production setting. I want to give you some suggestions, some hints, some links, not going into details. So, you may ask how to choose a good language model. First, I would like you to read this great blog post on benchmarks by Omar Sanseviero of Hugging Face, which tries to explain the different benchmarks we have, and then some tips to take with a grain of salt. If you want to look for good base models, you should go to Hugging Face Open LLM leaderboard, but these are models probably to be fine-tuned, not, as we have seen before, we don't use this in real-world applications. For chat models, I suggest this LM6 Chatbot Arena leaderboard, where users blindly judge models, and we have a Nilo score. And for Italian models, yeah, the community is maintaining a great Open ITA LLM leaderboard, which is growing, and I suggest you to check it out. Another important topic is the inference solutions. So where does my model run? And we have seen proprietary models like OpenAI. You call an external API, you pay per tokens. There is the option to have open models on-premise, but we can also use open models hosted by providers. And in this case, if you use a shared hosted model, you pay per token. If you use a privately hosted model, you usually pay per hour. But I want to focus a moment on open models on-premise. So if you want to do local experimentation, if you have GPU, you can probably use Hugging Face transformers on Colab, on Kaggle. If you only have CPU, there is Ollama and also the original project Llama CPP. If you have plenty of GPU resources and you have to serve something that should be fast and efficient in production, there are two main projects. One is VLLM and the other is Hugging Face text generation inference. But in this link, then I'll provide you the link to the slides. But in this link, I'm explaining all these different possibilities. Another topic, very important topic, when you go to production is evaluation. The evaluation is still a growing topic in this LLM world, but yeah, I give you some concepts. You can think of evaluating single components, such as the retriever, so you evaluate if the right information is retrieved. You can also evaluate the end-to-end pipeline, so if the right response is generated. And there are statistical and model-based methods. The statistical ones, you have to provide labeled data. Model-based, you use another model to evaluate. So you don't need labeled data in this case. And I suggest to look at the Haystack evaluation docs. And also, there are also other frameworks to do that, open source frameworks, and Haystack integrates with DeepEval and Ragas, which are focused only on evaluation. Obviously, another topic is deployment of your program, let's say, of your application. Here I'm talking particularly about Haystack. Haystack pipelines can be serialized to YAML, and they can be served using this little project called AUX. In this case, you run AUX run with your pipelines directory, and your pipelines are served as fast API endpoints. So you can call them, and you can create also a web application based on them. AUX is based on fast API, and for Haystack you can also find deployment guides for Docker and Kubernetes. What you can build with language models goes beyond RAG. And I want to talk just for a moment about recent projects done with Haystack. In this multilingual RAG from a podcast, I was interviewed in an Italian podcast, but I wanted people to ask questions about this interview in English, and so I built a simple pipeline with a transcriber, with a multilingual embedding model, and then a multilingual generator And yeah, the nice thing is that in the end, yeah, you can ask these questions and get responses in English, but the original text is never explicitly translated. You can find this project and others in the Haystack cookbook, which is a repository. Another interesting application, I think, is information extraction. You probably know classic ways to do that, name identity recognition, classification. The nice thing about using a language model for this is that you can dynamically define the structure you want to be extracted. For example, in this case, I want people, companies, but I also want a summary of a certain article. I want to know if it talks about animals, if it talks about AI, and I can change this schema and apply it right away, and it works quite well. Yeah, last week I shared this demo. This is nice, but not very complicated. The idea is you pass an URL to a language model and you generate a multiple choice quiz you can play with, but you can also let the language model play with it in a closed book fashion or accessing to web. So the language model never sees the original source, but can find other related information. So there's a lot of things that you can try and you can build with the language models. There is much more. Yeah, some of these features in this slide, they are simple or classic, for example, file conversion, but as you may imagine, yeah, extracting text from different types of documents in the right way is very important to make this language model reason on these sources. There is observability of this application once they are deployed, so logging, monitoring, tracing. Haystack has some stuff around observability, even if I'm not an expert. Then about capabilities of language models, probably one of the most interesting ones is function calling, so the ability of these models to provide a structured response, to prepare a call for a function, not invoke the function, but yeah, this makes it easier to integrate the language models in deterministic classic applications. And then there is a whole new area of agents, and this is the topic probably for another talk, but I want to give you a last word about this recent blog post by Berkeley AI Research, and they are seeing this, and I agree with this opinion, they are seeing this shift from single models that can do something to compound AI systems. So in this case, the model is just a component of your system, which is more complex. And so you can realize applications that are a mix of deterministic and statistical components. And while language models could be also, or maybe in the future, they will be commoditized, we can see a lot of value in integrating them in application. And yeah, thank you for your attention. And
thank you.
You can find also the slides on GitHub. Check out Haystack. Yeah, send me a connection request on LinkedIn if you want. And probably, yeah, I was too fast.
No, we have a lot of interesting questions here. So just to remind everyone, you can go online and ask your question. I will read it out for you. You can also upvote the existing questions. So we can start with the first one. How can we judge the answer given by the RAG? Do we need a human to classify them as correct, not correct? Are there solutions to do it automatically?
Yeah. This is about evaluation of RAG systems. And I provided some links before. The idea is that, yeah, you can do it as a human, provide labeled data or label them. The previous talk was by David, who works at Argilla, and Argilla is a data annotation platform which also helps with this. But another idea is also to use powerful language models to judge the responses. So there are many metrics with names that are fastly evolving, but faithfulness, correctness. So you ask to the language model with a specific prompt to evaluate the response. And I think that previously we were mostly using GPT-4, which is a powerful model to do that. But in the last months and weeks, there are also open source alternatives which are trained to judge what other models do. So it's not mandatory to use GPT-4. And yeah.
Thank you. Second question, how does Haystack differ from something like LangChain?
No, the value proposition, I think it is the same. Orchestration frameworks like LangChain, Llama Index, and Haystack, they are in the same pool, and they try to make it your life easier. Yeah, probably with Haystack is designed with some software design principles in mind. So we want to make your life easier without hiding too much stuff. So I haven't shown this to you, but creating a custom component or customizing an application with Haystack, usually it is easy and it is taught in this way. So yeah, it is the same pool, but we do different software design choices, and we hope that you can find it easier to customize. We are also committed to not release, to not do not announced breaking releases. And we are committed to software principles. Yeah, I would say that.
Thank you. Next question. Why do models provide the wrong answer, hallucinate, instead of saying they don't know?
This is, the reason is that they are trained the original training teaches them to provide a statistical plausible answer. So they generate text, and we like them also for this reason. You can use for creative things. And so probably with the current architecture and training, we can't avoid hallucination. what we are doing is passing the right information, then you can evaluate is the given response is grounded with the information, but this statistical nature of creating a plausible text, does not go away, I think. Yeah.
Thank you. We still have a few questions. We have 10 minutes left, so keep the question coming. What are good models to start for a beginner?
It depends. Also, if you want to start to build something, as I've shown, you can start with OpenAI models. If you want to pay, it's the easiest thing, but you can also switch to Ollama, and then so in your local machine you can run these models. And I have shown I was using Mistral, which is a 7 billion parameters, so it can run in your local machine in a normal laptop. You can also use Llama 3 8 billion parameters. There are, I think that to start in your local machine, you should look for 7, 8 billion parameters models or less. And so in these days, probably I would use Llama 3, but yeah.
Thanks. So next question is about the documents. So what are the formats of the given documents? Could they be search engine results about my topic?
Yeah, they can. As I was showing in this WebRag application, the first component, which does search on Google, it produces documents. In Haystack, documents are simple, a very simple abstraction with a content, and the content contains text, but the document format also has metadata, so you can write JSON things. You can put whatever contains text. I also know of a person who played with data frames, but this person is him. You can push data frames to documents.
The question is going to be about what are your thoughts on AI search engines, such as Perplexity or Arc Search?
I'm not an expert user, so I don't have strong opinions about them. Probably they work, and probably for this WebRag application you can just ask Perplexity. For when you want this, when you want an application that can reason on your data, you have to do something different.
Thank you. I don't have any more questions online. Anyone from the audience wants to ask a question? Sorry. I need to come with the microphone.
What problem can you find when you are going to production?
No, you can probably find several different types of problems, but probably evaluation is important. Also, maybe you want also in the future to replace your model with a new model, and evaluation is crucial, but also this part about observability, I haven't talked about this, I'm not an expert, but we integrate with some observability some open source observability solution and also new open source packages for LLM observability. So this can help monitoring what is happening. And also, I haven't talked about all the risks related to security, so prompt injection and other stuff. But you can find more information on Haystack. But yeah, I think these are important topics. Yeah, and also real world enterprise obviously care also about these risks, also about trust. Yeah.
Do you think that it's an easy tool to start a new project? For example, now you have some log files to parse, and you want to get some patterns, some information out from those log files. Is it easy to use this tool for this kind of new project?
What do you want precisely to do with these logs?
I want to train a new model using some log files. They have timestamps for information like, for example, pointer data, which is changing every time, of course, but you want to catch something.
And what is the
goal is to catch, if some test cases are failing, for example, and there are failures that you are not able to recognize normally. Then maybe there's something hidden.
Okay. No, currently Haystack is not focused on the training part. So if this involves if this involves training, I would suggest other tools. Yeah, there are many. I don't know. For example, I don't know if for your specific problem you need language, or you can reason on more structured numerical data. I don't know, but there are several other options. Currently, Haystack is just focusing on building with models you trained in other platforms. Yeah, also for language models training, there are many more good projects. Yes, so sorry.
I have another question online. How does Haystack play along with Kubernetes?
Yeah, we have these deployment guides, which one of these deployment guide is about Kubernetes. I think there is also another guide about OpenShift deployment. Not an expert, but yeah, these deployment guides have been written by my colleague, who is strong in DevOps. So I recommend you to read them. Yeah.
Any other last question? We have time maybe for one quick one. Okay, so thank you very much.